The next presentation will be held by Clèment Lemoine from AGC. He led the innovations and the new business development since 5 years at AGC, and it's now driving the market and product development for the Fineo product. And the topic will be vacuum insulating glass, innovations, applications, and how you overcome design and legal challenges. So the stage is yours.
Thank you for the introduction. It's a great pleasure for me to be here in this awesome environment. So today I will follow this agenda. So first, quickly introduce the topic, the technology, the VIG technology. Then some design installation requirements aspects. Then I will showcase some project examples. Then a quick overview of the certification framework, and I will conclude with some key takeaways. So the purpose for today is to give you a quick overview on these different topics, not to jump into the details because we would not have enough time. So to begin, let's make a bit of history regarding the evolution of the insulated glazing unit. And let's begin our story in 1950 with the Sigon glazing unit with very bad U value around 5 to 6. And from this point, we decided, okay, what can we do? How can we improve it? And so 10, 20 years after, come up the double glazing unit, which consists of 2 sheets of glass separated by an air gap. And at this point, okay, we had a U value from 3 to 4, and the question was again, what can we do? How can we improve it? And so let's play on the 3 different mechanisms for the heat transfer, which are the conduction, the convection, and the radiation. So regarding the conduction, let's play on the spacer, and specifically on the warm edge spacer, to diminish drastically the thermal bridge effect. Regarding the convection, let's introduce real gas instead of air in 1 or 2 cavities of the glazing units, so from switching from double to triple glazing unit. And regarding the radiation, let's introduce low emissivity coating to block infrared radiation. And so at this point, okay, we had insulated glazing unit, which gathers all the features we just saw with good U value around 1. And the question was again, what can we do? How can we improve it? And so let's suppress the convection with vacuum and introduce the concept of insulated or vacuum insulating glazing unit, which allows us to reach low U value around between 0.3, 0.7, what you can find actually on the market. And concretely speaking, what is the skeleton of the VIG? So basically, it's 2 sheets of glass, either annealed or tempered, separated by a narrow vacuum gap between 0.1 and 0.3 millimeters. These 2 sheets of glass are sealed with a material. It can be either a ceramic one or metallic one. To avoid the two sheets of glass to collapse on each other, because due to the atmospheric pressure, we will introduce pillars between the 2 glasses on a gird, which can have between 12 millimeters to 50 millimeters pitch. And of course, we will introduce this low emissivity coating to reach this superior U value, as I said before, between 0.3 and 0.7. And in the cavity, and as well, we will introduce what is called the gaiter. So the gaiter is like a sponge, and the purpose is to absorb the residual gases in order to maintain the vacuum during the lifetime period of the VIG. Here you have the main features of the VIG. It's a non-exhaustive list, but those are the main ones. So of course, like I said before, there is a superior thermal insulation with a low UG, an ultra-thin design. So usually to reach this level of insulation, you should play with a double glazing unit, triple glazing unit with several coatings. Here, with the VIG, you can reach this level of insulation with a thickness between 6 to 12 millimeters. Of course, you have what we should highlight, a good acoustic performance, what is called the noise reduction, expressed by the RW value of, and it's around 36 dB what you can find on the market for a standard VIG. Durability, so you have a very good lifespan of the VIG. VIG suppliers expressed a warranty period from 15 to 20 years. And the lifetime period is quite high, so going from 25 to 60 years, what you can find on the market. And last but not least, the recyclability. The product is 100% recyclable, so you don't need to dismantle all the elements. You can recyclable completely. Okay, so now let's have a look on the design and installation requirements that should be fulfilled to enable the VIG to have these optimum performances. So when you design insulated glazing unit, you should take into account different loads. But for the VIG, there are two loads that are unique. The first one is the pillar ones, and the second one is the thermal one. So the pillar loads, it's actually the counter reaction to the atmospheric pressure, as I said before. And so due to this, the pillar will have a counter effect and created local stress on the edge of the glass, as you can see here on the sketch. Regarding the thermal load, so it's the most complicated one. In fact, when you install a VIG, of course, you have a high level of insulation, but most of the case, you have a high differential temperature between the inner glass and the outer glass. And due to this, and due to the fact that the two glasses are sealed together, the VIG will tend to bend towards the outer side of the VIG. I will detail quite a bit the load after. Of course, you have to take into account external loads, basic one that you consider also when you simulate the loads in a standard IGU. I take the example here of the basic wind load. And of course, important highlights. So on the opposite of the standard insulated glazing unit, you don't need to consider the climatic load because you have vacuum and so not air in the cavity, so you won't have the pumping effect inside the VIG. So basic, the thermal load, as I said before, is the most critical one to consider, and you should respect strict installation guidelines to enable the VIG to have not to break, let's say. Why? So we took a numerical simulation here for a freestanding VIG for the thermal load, and theoretically, so the VIG will bend, and you have a specific load in the middle. But most of the time, the VIG is installed, it's fixed in the frame, and so if you look at the stress, they are not in the middle, but located on the edge of the VIG. That's why you need to absorb this stress, and to avoid glass breakage, you need to introduce what we call flexible PUT, flexible gaskets, with a criteria what I call soft and thick enough. And the soft and thick enough criteria of these elements should be defined by the VIG supplier to avoid the breakage between the VIG and its frame. So you have some examples here of installation taking into account this soft and thick enough criteria with PUT, with joint sealing foam, with flashing PUT. You can have many others, but I will detail quite a bit the soft and thick enough with a concrete example after. Okay, so concretely speaking, let's take this canal project which has been done in Brussels. So it is an old building which managed to be restored in two ways. The first way was modern facade, with a new frame, and the second way was an existing facade, so reglazing of an existing facade. Both of framings are made of steel, and for that purpose we used this VIG, so low iron one, with a thickness below 10 millimeters. And the purpose, so the VIG was meant to be installed for the basic value proposition is to achieve the highest thermal insulation with the minimal thickness in order for the VIG to fit in the existing frame. And so as I say, okay, let's apply the installation procedures. And so for the new steel profile, we will have a combination of low-Young modulus, PE foam and QT, so that were used for this window. So you have here the sketch of the different elements of the window, but what's interesting to see is the different features and values. So of course the UG of 0.7, the U window of 1.48, noise glass insulation, as I said, 36, GP, a nice light transmission on 84%, and thickness, as I said, below 10 millimeters, and weight below 25 kilograms per square meters. And for the all steel profile, it's the same. So a combination of low-Young modulus, PE foam, and QT was used. And what's interesting to see here is that the U window is higher because of the absence of thermal bridge effects in the existing frame, because we're reusing an existing frame. What I would like to highlight now is, okay, if we take a bigger overview about the different market segments VIG could tackle, the VIG was originally designed for the restoration renovation market, saying that you should be able to install the VIG in existing frames. But we see more and more projects where VIG can be a highly suitable solution for new windows, new facades. Okay, so now let's have a look on the certification framework aspect, because we see more and more questions raising on this topic. And so let's ask ourselves the question, okay, I have a new construction product. What are my obligations if I want to sell it? And let's say we have two ways. So the first way, there is an harmonized product standard existing. And if I'm in this case, no question, it's mandatory to use the CE marking. The other case is I do not have harmonized product standards. And in that case, it will be a voluntary way. So a voluntary way on the national scale, using a national certification assessment, which would be handled by the national notified bodies. Or it can be also as well a voluntary CE marking on European scale, so using a EAD, a European assessment document that should be signed and granted by the European Commission. And so, of course, for the VIG, as nothing is easy, we are in the second case with the non-harmonized product standard existing. So we should use the voluntary way. And for you to know that an EAD has been signed by the end of 2024 by the European Commission. Okay, that's already the end. So I would like to conclude with some key takeaways I would like you to bring back home with you. So the first one is that VIG, we saw it in the presentation, does offer exceptional thermal and acoustic insulation while maintaining a slim and lightweight profile. This is the value proposition, the main value proposition of a VIG. Second, you should use specific installation guidelines when you are dealing with a VIG due to the loads and specifically the thermal loads you should be careful, and this installation guideline should be explained by the VIG suppliers you're working with. The third point, VIG offers a product that could be applied for a wide range of application, of use cases. As I said, it was first designed for the restoration renovation segment, but we can see that more and more new construction projects, new windows projects want to use the VIG in the new framing system. And the last point, so for the moment, VIG remains voluntary certified, so you should use the voluntary way, but this is expected to change in a few years with the new standardized framework being developed, so in the next 5 years, I think. Thank you. And if you have any question,